Let me tell you about something that is happening right now. In hospitals, in factories, in skyscrapers, in airports, in power plants, in entire cities, that most 3D artists have absolutely no idea exists as a career opportunity. Not because it's new. It's not that new. Not because it's small. It's enormous. And not because the work is too technical or too difficult for skilled artists to do. Because nobody in the 3D career conversation is talking about it. Here's a question. What if I told you that there's a sector of the 3D industry, a growing, well-funded, expanding sector, where companies are spending enormous amounts of money to have skilled 3D professionals create accurate, detailed, real-time digital replicas of their physical buildings, machines, cities, and infrastructure. And that these replicas aren't made once and shelved. They're used every single day, updated continuously, maintained by teams of people, integrated into how companies operate, plan, train their staff, and make decisions worth millions of dollars. And that the 3D artists who understand this space, who know how to create this type of content, who speak the language of the industries that need it, are being hired at rates that would surprise most people in the traditional 3D art community? That's not a hypothetical. That's digital twins. And it is a $100 billion industry by current estimates that is growing fast, with a genuine shortage of 3D artists who understand it. I've been sitting on this topic for a while because it requires some explanation to do justice to it. But I think it's one of the most important career conversations we can have on this channel right now. So let's have it. Here's what this video is going to do. I'm going to explain what a digital twin actually is, simply, clearly, in plain language. No industry jargon that makes your eyes glaze over. I'm going to show you the specific industries that are spending real money on this right now. I'm going to walk you through what the actual work looks like for a 3D artist in this space. I'll show you the money, realistic income ranges, and I'll give you a clear picture of what skills you need and how to start building toward this as a career direction. By the end, you'll understand what digital twins are, why the opportunity is as significant as I'm claiming, and what your specific next steps are if this sounds like a direction worth exploring. And I want to be honest up front about something. This is not the easiest career path I've talked about on this channel. There's a learning curve. There's domain knowledge to develop. It takes time to build credibility in these industries. But the payoff in rates, in stability, in the type of work, makes that investment worth understanding clearly before you decide whether it's for you. Let's build the picture. Before the explanation, I want to share something that changed how I think about the value of 3D skills entirely. Most 3D artists think about their work in terms of deliverables. A render, a model, an animation, a visualization, something that gets made, gets delivered, gets used, and then sits in an archive somewhere. That mental model, create something, deliver it, move on, is how most of the 3D industry works. And it's fine, but it puts a ceiling on how much a single project can be worth because you're selling a finite thing with a finite use. Digital twins are different in a fundamental way. And when I understood what that difference was, it completely changed how I think about where value lives in the 3D industry. A digital twin is not a deliverable. It's a living asset. It doesn't get created once and shelved. It gets created and then it gets used continuously as an operational tool. Updated, maintained, improved, integrated into how an organization functions. And because it's a living asset rather than a finished deliverable, the relationship between the 3D professional who creates and maintains it and the organization that uses it is completely different from the client-project delivery relationship most artists are used to. But here's what I want to flag before I explain fully. The reason digital twins are growing so fast, the reason companies are spending so much money on them right now, is not primarily about 3D visualization quality. It's about something more fundamental that has very little to do with how good the renders look. I'll show you exactly what that is. But let me explain what a digital twin actually is first, because everything else makes more sense once the concept is clear. A digital twin is a precise, detailed, real-time digital replica of something that exists in the physical world. Let me make that even simpler with an example. Imagine a hospital, a large, complex hospital with dozens of departments, hundreds of rooms, thousands of pieces of medical equipment, miles of pipes and electrical systems running through the walls. This hospital was built 40 years ago. Some of the blueprints are missing. Some of the infrastructure has been modified over the decades without proper documentation. The facilities team is responsible for maintaining everything, but half the time, they don't know exactly where a specific pipe runs or what that cable connects to. Now imagine that someone created a precise 3D model of the entire hospital. Every room, every corridor, every piece of infrastructure, modeled accurately and linked to real data. You can open it on a screen and navigate it like a video game. Click on any door and see when it was last serviced. Click on any pipe and see what it connects to and what its current pressure reading is. Click on any piece of equipment and see its maintenance history, its warranty status, the last time it was inspected. That's a digital twin, a precise digital replica linked to real-world data, used as an operational tool by the people who manage and maintain the physical thing it represents. Now, scale that concept. Not just hospitals, factories, power plants, airport terminals, oil refineries, office buildings, data centers, entire city districts, railway networks, offshore wind farms, military bases, any complex physical infrastructure where understanding, managing, and optimizing the physical environment saves significant time, money, or risk. These are all active markets for digital twin creation and maintenance. And all of them need skilled 3D professionals to build and maintain the digital assets that make them work. Okay, the thing I teased in the incomplete loop. The real reason behind the spending. It's not about pretty visualizations. It's about decisions. Specifically, the ability to make better decisions about expensive physical things without the risk of getting them wrong in the real world. Here's what I mean. When a manufacturing company wants to reconfigure their factory floor, moving machines, changing workflows, optimizing the layout for a new product line, they have two options. Option 1, move the physical machines. Hire contractors. Stop production for a period. Try the new layout. Discover it doesn't work quite right. Move things again. Stop production again. Figure it out through expensive real-world trial and error. Option 2, reconfigure the digital twin first. Test the new layout virtually. Run simulations to check the workflow efficiency. Identify problems before moving a single piece of physical equipment. Then, when they're confident the layout is right, make the physical changes once, correctly the first time. The cost difference between these two options on a significant factory reconfiguration can be in the hundreds of thousands of dollars, sometimes more. The digital twin pays for itself on a single decision. Now multiply that across the lifetime of a complex facility. The thousands of decisions that get made about maintenance, optimization, safety, training, emergency planning, regulatory compliance. Every one of those decisions is better when informed by an accurate digital twin. This is why the spending is real and why it's growing. Not because companies want impressive visualizations, because accurate digital models of their physical assets save them money on decisions. And the money they save on decisions is multiples of what the digital twin costs to create and maintain. Let me get specific, because digital twins are everywhere is too vague to be useful for career planning. Manufacturing and industrial facilities. This is the largest current market. Factories, production facilities, warehouses, processing plants. Companies in automotive manufacturing, pharmaceutical production, food and beverage, electronics assembly. All of them are investing in digital twins of their production environments. The primary use cases are layout optimization, maintenance planning, safety training, and production simulation. The companies in this space have real budgets, long-term contracts, ongoing maintenance needs. This is not a one project and done market. Real estate and facilities management. Large commercial real estate, office complexes, shopping centers, hotels, hospitals, universities is actively investing in digital twins for facilities management. The goal is to manage complex buildings more efficiently, know where everything is, Plan maintenance proactively. Optimize energy use. Manage space allocation. Plan renovations before breaking ground. This market is enormous because the inventory of large, complex buildings that would benefit from a digital twin is enormous. Infrastructure and utilities. Water treatment plants, electrical grids, gas distribution networks, transportation infrastructure. These are complex, critical systems where errors are expensive and dangerous. Digital twins allow operators to understand their networks precisely, plan maintenance and upgrades, train staff safely, and respond to problems faster. Government and utility contracts in this space are large and stable. The clients are not going anywhere. Smart cities and urban planning. This is the most emerging and in some ways the most exciting application. Cities around the world, Singapore, Helsinki, Dubai, many others, are actively building digital twins of their urban environments. Street networks, building stock, utility infrastructure, transportation flows, environmental monitoring. Used for urban planning, emergency response planning, environmental simulation, infrastructure investment decisions. This is genuinely a growth market. More cities are starting these initiatives every year. The scale of the work is significant and the budgets are substantial. Defense and aerospace. Military bases, aircraft, naval vessels, defense installations. High-stakes environments where understanding the exact state of physical assets is operationally critical. The budgets in defense are significant, and the security clearance requirements create a barrier to entry that reduces competition for artists who can access this market. Now let's talk about what a 3D professional in this space actually does. Because build digital twins is a concept, not a job description. The work breaks into a few distinct areas. Reality capture and reconstruction. This is the starting point for most digital twin projects. The physical asset needs to be accurately captured, documented in enough detail to build a precise 3D model from. This is done through a combination of laser scanning, photogrammetry, architectural drawings, and engineering documentation. As a 3D professional, your role here is to process this captured data, point clouds from laser scanners, photogrammetry models from drone or camera surveys, and turn it into clean, accurate, navigable 3D geometry. This is a specific technical skill. It's learnable, and it's one of the most in-demand skills in the digital twin space right now. 3D modeling and geometry creation. For assets that haven't been captured via scan, or where the scan data needs supplementing, traditional 3D modeling applies. But modeling for digital twins is different from modeling for visualization. Accuracy is the priority. Every measurement matters. The model needs to reflect reality, not approximate it. This discipline, sometimes called BIM, Building Information Modeling, in the architecture and construction space, is well established and has its own software ecosystem. Visualization and real-time environments. Once the 3D geometry exists, it needs to be presented in a way that the people who use it can navigate intuitively and extract value from. This is where visualization skills directly apply. Unreal Engine is increasingly used for high-end digital twin presentation. Exactly the skills we've been discussing in the UE5 track. The ability to create a navigable, visually clear, real-time environment from complex geometric data is a genuinely valuable skill in this space. Data integration and management. The thing that makes a digital twin more than a model is the data attached to it. Sensor readings, maintenance records, asset specifications, operational data. Linking this data to the 3D geometry is partly a technical task and partly a design task. Deciding what information to show, how to show it, how to make it accessible to the people who need it. This work sits at the intersection of 3D skill and UX design thinking. Let's talk about what this work actually pays. Entry-level 3D roles at digital twin companies and in BIM-focused visualization studios, $55,000 to $75,000 in established markets. This is comparable to other entry-level 3D positions, but with significantly better job stability, because the projects are long-term rather than project-based. Mid-level professionals with 2 to 3 years of specific digital twin or BM experience. 80 to 110,000. This range reflects the value of the domain knowledge on top of the 3D technical skill. Most companies pay a premium for people who understand their specific industry, manufacturing or healthcare or infrastructure, in addition to the 3D work. Senior specialists and project leads in this space, 120 to 160,000 in major markets. These are people who can manage complex digital twin projects end-to-end, from reality capture through to delivery and ongoing maintenance. Freelance and consultancy rates, $100 to $200 per hour for experienced specialists. The project values can be large. Digital twin projects for major facilities regularly run into the hundreds of thousands of dollars. And here is the thing that makes this market different from most 3D work financially. The relationships are long-term. A company that invests in a digital twin of their facility needs it maintained, updated, and expanded as the facility changes. That's ongoing work, often for years. The retainer model, which we discussed in the product viz context, is even more applicable here because the use case is genuinely ongoing rather than episodic. Here's the clear picture of what you need to build toward this space. Foundation skills you may already have. Strong 3D modeling, specifically accurate, measurement-based modeling rather than artistic freeform modeling. If you can model accurately to reference, this skill transfers directly. Real-time environments. UE5 experience is increasingly valuable for digital twin visualization. The skills from the UE5 track on this channel apply directly. If you've been building your UE5 foundation, you're already building toward this. Attention to technical detail. Digital twin work rewards artists who care about accuracy and completeness rather than just aesthetic quality. Different from product viz, different from VFX. Accuracy over beauty. New skills to develop. Point cloud processing. Learn to work with LiDAR and laser scan data. Software like Autodesk Recap, Leica Cyclone, or various open source options. This specific skill is genuinely in demand and relatively underrepresented in the 3D artist community. BM fundamentals. Understanding how building information modeling works, the data structures, the standards, the workflows. Autodesk Revit is the industry standard software. There are free learning resources. Fundamental understanding of BM concepts is the domain language of architecture and construction digital twins. Industry domain knowledge. Pick an industry: manufacturing, healthcare, infrastructure, real estate. Learn how that industry works. The language, the concerns, the workflows, the regulations. A 3D artist who understands how a hospital is managed, or how a factory production line works, or how a utility network is operated, is significantly more valuable to clients in those spaces than an artist who only knows 3D. Your first step this week: download Autodesk's free resources on BM fundamentals. Spend 2 hours understanding what BM is and how it relates to digital twins. Then search LinkedIn for digital twin and look at the job listings, not to apply now, but to understand what the market is actually asking for. Read 5 job listings carefully. Notice the skills they ask for. Notice the industries. Notice the software. That 2-hour research session will give you more clarity about this market than anything else I can tell you. Now, something I want to flag about the digital twin space that changes how you should think about entering it. Unlike product visualization, where your portfolio is primarily what gets you clients, in the digital twin space, credibility is built differently. Clients in manufacturing, healthcare, and infrastructure are not browsing ArtStation. They're not evaluating render quality. They're evaluating whether you understand their world well enough to be trusted with their operational infrastructure. Which means the path into this market is not build a portfolio and start reaching out. It's something more specific than that. And it requires a particular strategy for building credibility in an industry that doesn't know 3D artists exist yet as a resource for what they need. That strategy, how to build credibility in a new industry, how to find the right entry points, how to position your 3D skills as the solution to a problem that clients in these industries are actively trying to solve, is something I want to go through specifically, because the opportunity is genuinely there. But the path looks different from every other path I've described on this channel. And knowing that difference before you start saves you an enormous amount of misdirected effort. That's the next conversation. How to actually get into markets like digital twins when your background is 3D art, and there's this industrial engineering or healthcare management or urban infrastructure. So, digital twins. The $100 billion 3D industry most artists don't know exists. A precise digital replica of a physical asset, building, factory, city, infrastructure, used as a living operational tool by the organizations that manage those assets. Not a deliverable. A living asset with ongoing value and ongoing maintenance needs. The industry is spending real money right now. Manufacturing, real estate, infrastructure, smart cities, defense. The work, reality capture, accurate modeling, real-time visualization, data integration. The rates, strong, stable, long-term relationship-based. The skills to build, accurate modeling, real-time environments, point cloud processing, BM fundamentals, industry domain knowledge in one specific sector. Your first step this week, 2 hours. BM fundamentals. 5 LinkedIn job listings. Understand the market before you decide whether to enter it. This is not the flashiest career path. It is one of the most stable, well-compensated, and genuinely underserved by skilled 3D artists of any career path I know of in this industry. Subscribe if this kind of career exploration, the doors most people walk past, is what you come here for. Hit the bell for the next video because the strategy for actually getting into non-traditional markets as a 3D artist is the piece that makes this opportunity accessible rather than just interesting. And drop a comment. Had you heard of digital twins before this video? And does this feel like a direction that could make sense for your background? I'm genuinely curious and I read every single one. I'll see you in the next one.